Okay, we've defined engineering data, geometry, and now we have to set up the model. Actually, in the next step, we'll solve all the remaining cells of static structural system. When we double-click on a cell model, Ansys opens another application called Mechanical. This is the environment in which we do most of the work. All the important tools or options are gathered in the ribbon on top. They are organized into smaller groups like Outline, Solve, Insert. When you switch tabs, also the ribbon with tools changes. Tabs such as File, Home, Display, Selection, and Automation. They're always there, but there is one special tab that is context specific. What this means is that when you navigate through the tree structure, options in that tab change to those that are relevant to the context. Depending on the selected object in the outline, also details change. Details pane, this is where you will assign attributes of the model. And lastly, for manipulating views and selections, you can find options in Graphics toolbar. Okay, enough introduction, let's get modeling. Again, as in Workbench, we'll go step by step over tree structure to get all green ticks. First question mark is under geometry. Usually what is missing is an attribute of a certain part, either material assignment, thickness of a shell, or cross-section of a beam. Ansys helps you find it by highlighting a missing property. So let's give him what he needs. We choose aluminium that we have defined earlier. Yes, we have a green tick. Next, we have mesh. This is an important topic, but let's do it quickly so we get to the solution as soon as possible. Leave all the settings at default and generate mesh. You can do that either in the Context tab or by double-clicking on Mesh object in the outline. It takes some time and then voila! And now the final step before solving, we define supports and loads. This bracket is fixed to a flat surface with 4 bolts. It has a shaft fitted in the 2 holes and is loaded in the right and slightly upwards direction. To insert the support, select Fixed in the Context tab and start selecting areas on which it is applied. To select multiple objects, you have to hold Ctrl key, as is the usual practice. Maybe you might need some rotate, pan, and zoom options that are available in Graphics toolbar, but even more convenient is to use shortcuts. Scroll wheel for zoom in, zoom out, scroll wheel button for rotate, and right-click drag for zoom in on area. When you have selected all 12 faces, click Apply besides Geometry in the details of Fixed Support. Next, let's define loads, choose Force in the Context tab. Maybe you have already autofilled 12 faces that were chosen before, so we need to override that. Again, select all 4 faces of the 2 holes and apply it to the geometry of the force. Let's define the force by its components and say its Z component is -1000 newtons and its Y component is 500 newtons. All that in global coordinate system. And the reason why we define Z component as negative value because we wanted to define it in the negative direction of global coordinate system. You can also see a little arrow showing the direction of the force, and this is like a rough check whether we've defined the direction of the force correctly. Geometry, check. Materials, check. Mesh, supports, force, check. We're all set to throw this to a solver. How do we do that? In the Context tab of Static Structural, click Solve. And now we wait. We can follow the progress in the status bar. It's a small model, it should be soon. And we're done. Supposedly we have a solution, there is a green tick, but we don't see a solution. Well, we have to tell Ansys what we want to see. Obviously we want to see a deformed shape. So we go to the Context tab and select the deformation and total. Then we might also want to see some stress. Let's choose von Mises equivalent stress. And finally we have to tell Ansys to retrieve the results from results file. Right-click on solution and select Evaluate all results. Clicking Solve does the trick as well. Now you click on Total Deformation and you see a deformed shape. If you want to see the animation, click on Play icon. Wow, what a lovely animation. If you by any chance don't see Graph pane, go to Home tab, Manage, and turn on Graph. Here you will also turn on Outline and Details pane if you have accidentally closed them. Anyway, let's see what we can get from the results. There is a scale on the left that tells you what colors mean. You can find maximum and minimum deformation written on the top, and also in what units these numbers are given. If you would like to change them, click on Units in status bar and it updates it instantaneously. Finally, we go to the equivalent stresses. We can find maximum stress where the red contours are, and apparently von Mises stress there is just above 25 megapascals. So that's that and we're done. Nope, not really. We've done plenty of mistakes, so keep watching the next video to see how to do it better. See you there! Oh, have you subscribed yet? Why not?